10 minutes. I'm going to do a couple more. I'm going to make this one a little bit messy. So I want to integrate x cubed e to the 2x dx. So again, if this is my problem and I'm going to walk up to it and say to myself, is it algebra, trig, or a mixture of stuff? Well, it's a mixture. I've got an algebra piece and an exponential piece. I'm going to check, is it a u substitution? Well, the derivative of x cubed is 2x squared, which I don't have anywhere. And the integral of e to the 2x would be 2e to the 2x. And I don't have another e to the x. So I think I'm stuck, which means it must be integration by parts. I'm looking at a mixture of algebra and exponentials and thinking, who comes first in the word late? Algebra comes first in the word late. That a comes first in the word late, which would make u x cubed and everything else dv. To get back to what I need for my ultraviolet voodoo, I need a derivative of u and I need the antiderivative from dv. Remember, the antiderivative of e to a number times x will be 1 over that number, e to that number times x. Putting all of that together, we've got x cubed e to the 2x dx is equal to ultraviolet voodoo. So x cubed times 1/2 e to the 2x minus the integral of v du, 1/2 e to the 2x times 3x squared dx. I'm going to pause, rewrite everything neatly, because one of the hardest things about integration by parts is keeping track of all of the constants and negative signs. So I've got 1/2 x cubed e to the 2x. I've got a 1/2 and a 3, so I'll pull both of those out and have -3 halves times the integral of x squared e to the 2x dx. So now I look at that integral and I say, is it algebra, trig, or a mixture of stuff? It's still a mixture. Can I do a u sub? Doesn't look like it. So it's going to be integration by parts another time. There's my algebra piece and my exponential piece. If I let u be equal to x squared, dv will be e to the 2x dx. That makes du 2x, and it makes v 1/2 e to the 2x. Now we've got to get really careful. I'm looking at 1/2 x cubed e to the 2x minus 3/2, and now in parentheses, this is the integral that I'm swapping out for ultraviolet voodoo. So this piece of it becomes uv x squared times 1/2 e to the 2x minus the integral of v du, 1/2 e to the 2x times 2x dx. And again, for me, before I try to integrate this, I want to distribute all my constants and negative signs to keep track of it all. So I've got a -3/2 that's going to distribute here. I'll end up with -3 over 4. X squared e to the 2x. And then that negative 3/2 is going to distribute out here. Minus a minus, I'm going to get a plus. And then I've got 3/2 and a 1/2 and a 2. So the 2 and the 1/2 can cancel, and I'll just have that 3/2. And then I look at that, and I say, hey, is it algebra, trig, or a mixture of stuff? It's a mixture problem. It's still not a U substitution, so I need to integrate by parts again. If U is equal to X, dV is e to the 2x. So my V is 1/2 e to the 2x again. And my U here, or rather my du, is dx. And I'm going to have parentheses again, because this integral is what's getting replaced with ultraviolet voodoo. X 1/2 e to the 2x, that's my u times v, minus the integral of v du, so 1/2 e to the 2x dx. I'm almost done, but I'm also almost out of the board. So I'm going to try to squeeze it in. 1/2 x cubed e to the 2x minus 3/4 x squared e to the 2x plus, and now if I distribute that 3/2 in, 3/2 times 1/2, I've got 3/4 x e to the 2x, and then distributing that 3/2 in here, that'll be a minus that 3/2 times that 1/2 would give me 3/4, the integral of e to the 2x dx. But since I'm out of board space, I'm going to go ahead and integrate this one. We've now finished this integral 1, 2, 3 times, so we already know that this is going to be 1/2 e to the 2x. And don't forget the plus c. As